You see two laptop battery for down there, you don't spoil. You don't spoil.
I'm not sure if both of them are sparked.
No once, I won't destroy them.
You want to destroy am
Mm.
for wetin?
I beg, I study electrical. I want
Eh?
to play around.
See this joker.
I make power bank.
See na make power bank.
Yes.
Na so go cause fire now. Even if you cause fire, you just burn the device wey you wan charge.
Now
Try
you
test
go
am
use
with your
test.
phone. Test am with
Now
your
you go use test. Oh God.
phone.
You know what we use your own test.
Who make am?
You
Who
know what
make am?
witness greatness.
Who make am?
Hmm?
Who make the thing?
Me. That's the point. I
Uh-huh.
can't do the same,
What?
I've done the first part.
How?
Now that I step two phase.
Okay, like I said, this is a continuation of session 4. I'm going to continue from where we stopped. Before that, I will just try to give a little summary of what we did in the last class. So, last class we talked about data structures, and we're supposed to speak on file handling, but we couldn't do that, and that's what we'll be doing today. Please, can you see my screen?
Yes, we can.
Okay, thank you. So we discussed lists, the operations on lists, tuples, dictionaries, sets. So lists are comma separated items with an index, and they are always in square brackets. Is an example here. Is an example here, example of a list. We know that the indexing is off by 1, so the indexing always starts from 0, and then some of the operations you can slice, you can add items, update, delete, find length, maximum, minimum, and arithmetic operators. So slicing, we use the column in between the index from like 0 to 3. I remember that when you're slicing, the initial number is inclusive while the second number is not inclusive. So this will give us 0, 1, 2, like the values at index 0, 1, 2 as our output for this. So add items, we use our dot append. Then to update a list, we have to access the index using the square bracket and input the new value that we want. We also discussed how to delete items using DEL. So to delete items from a list, we put DEL, then the list name, then the index in a square bracket. Also how to find the length. Finding the length, we use LEN, that's just short for length. Then we'll put the name of the list in a bracket. To find the maximum and minimum is also similar. We use max and min, the name of the list. Then we discussed arithmetic operators also, like addition and multiplication. Addition is to concatenate lists, and multiplication is to repeat values in the list. Then we also discussed tuples, which are immutable. We said that tuples are comma separated values enclosed in a parenthesis, and they are immutable like lists, but we can perform some operations on them, like we can slice tuple values. To access, it's just the same way we do it in lists, and to slice is also the same way we do it in lists. We can also concatenate, which is addition. We also discuss the advantages of using tuples, like consistency and safety, and this is all because tuples remain unchanged. Yeah, we move to dictionaries from there. Dictionaries are key value pair, and a key value is called a record. Then they are enclosed in curly braces. Operations on dictionaries, updating, deleting, and determining the length. So dictionaries are not immutable, so they are mutable, unlike tuples. So to update a dictionary, instead of using index like we do in lists, we'll be using the key this time. Then we assign a new value to each key. To determine length, the same way we do it in lists, use len. To duplicate, for duplicate keys, we discussed that we shouldn't have duplicate keys because then we'll be getting the last key, the value from the last key instead of any other value. Then we moved on to sets. We spoke about a set being comma separated values in curly braces. So they use the same type of braces as dictionaries, but they don't have key value pair. Instead, they're just singular values. Then we check the operations like updating sets, deleting elements, union, intersection. So to update, we use dot add on like in lists and dictionaries. For set, we use dot add to update. To remove, we use dot remove. For union and intersection, we use dot union and dot intersection. So this is where we stopped in the last class, and I'm going to continue from here. So this class won't be very long because it's just a completion of the last class. So let's get into it. Starting from union, so I'll start from union and I'll go on. So union is used to merge elements of two sets. Intersection outputs the common elements of two sets. So I have set 1 and set 2. Set 1 is a set of even numbers 2, 4, 6, 8.
It will be
And
true.
set 2 is just a set of 1, 2, 3, 5, and 7, skipping 4. So when we want to find the union, we have to use dot union. I will take set 1 dot union set 2 and we'll get the union. We can put set 2 dot union set 1, give us the same value. For intersection, we use set 1 dot intersection set 2. We can also put set 2 dot intersection set 1. All those will give us the same values because it's just union and intersection. When we move on to difference, we would see that it doesn't work that way. But first, I'll demonstrate this. So I'll define a set 1, and set 1 is a set of even numbers 2, 4, 6, 8. Then I'm defining another set 2, which is a set of numbers from 1 to 7, skipping 4. So 1, 2, 3, 5, and 7. That's exactly what's in the slide. Then I want to find the union and the intersection. To find the union for this, we just do set 1 dot union. In the bracket, we put set 2. So to give us from 1 to 8, because that's all the elements we have. And in sets, we deal with unique elements. So we're picking 1 to 8, each, one element each, because that's unique elements. Then to find the intersection, we set 1 dot intersection. That's the old word intersection. Intersection. I'll put set 2. The old intersection is 2. Also remember I mentioned that when we do not have any intersection, we get an empty set. Also, I said we can use set 2 union set 1. It still give us the same thing because it's just union. We can also use set 2 intersect set 1. So use dot intersection set 1. So this is how union intersection works. So I'll give an example of how we can get an empty set. So I can define a new set 3, which would be a set of odd numbers. So I'll do 1, 3, 5, 7. And from above, set 1 is a set of even numbers. Then set 3 is a set of odd numbers. So I try to find an intersection between set 1 and set 3. There is no intersection. So we'll be getting an empty set like this. Set 1 dot intersection set 3. So we get an empty set like this. So yeah, this is how union and intersection works. Now to difference, which is the next. Means we're finding the elements of one set that are not in the second set. That's what difference means when it comes to set theory. We're trying to find the elements that are in the other set. So it's said here, difference returns a new set containing elements that exist to find the difference. So in sets, normally mathematics, difference, if you have two sets, maybe set 1 and set 2. Set 1 has its element and set 2 has its elements. Then we want to find the elements that are in set 1. Set So, for example, this is a sample code. Set 1 is 1, 2, 3, 4, 5, and set 2 is 3, 4, 5, 6, 7. So we want to find the elements that are in set 1 but not in set 2. Put by creating a variable result set is equal to set 1 dot difference set 2. And then want to print element what is in the slide. Please, somebody is raising his hand.
Yes, ma, I'm the one, ma. I was going to ask that question. Ma, I use them, what is it called? This sign, minus sign, and it works. I did not put this dot difference.
Okay, you put set 1 minus set 2, right?
Yes, and it works that way. I did not, I don't know, but it did not return anything like error to me. It worked, and it returned the result.
And it gave you the difference, right?
Yes, ma. You can also try that.
Okay, so I don't know if anybody here has like a mathematical background, or maybe you've come across set difference anywhere, but set difference is also like minus can also be used for set difference in set theory in mathematics. So it also applies here. So difference means the elements in one set are not in the other. Minus also means the elements in one set are not in the other. So I'm going to show both examples now. So we have set 1 and set 2 defined already. Let me copy them out so you can see them clearly. You already have set 1 and set 2 defined here. So now I want to find the difference between set 1 and set 2. Set 1 dot difference. Then I'll put set 2 in the brackets. So I'm seeing 4, 6, 8. This is because 4, 6, 8 are the elements that are in set 1 but are not in set 2. The only thing set 1 and set 2 have in common is actually 2. So we're bringing out the elements that are in set 1 but are not in set 2. As you can see, set 2 has 1, 3, 5, 7. But we're not getting that because we are focusing on set 1 and bringing out the elements that are in set 1 but not in set 2. We can also do vice versa and get the elements in set 2 that are not in set 1. So that way I'll put set 2 outside and I'll put in set 1 inside. So this way I'm getting 1, 3, 5, 7. That's the elements that are in set 2 but are not in set 1. So the way we could interchange what is outside the bracket and what's in the bracket for union and intersection, we cannot do that for difference. We have to know what we are looking for. So in this one, for the first example I did, we know that we are looking for the elements in set 1 that are not in set 2. So set 1 is the one that comes before dot difference, while set 2 is the one in the bracket. Then for the second one, we know that we're looking for the elements in set 2 that are not in set 1. So we're doing set 2 dot difference set 1. Now let's try out what he said. He said he did set 2 minus set 1. I see that we're getting 1, 3, 5, 7. So it means elements are in set 2 but are not in set 1 because minus in set theory means difference. Minus in set theory means difference. So if we do set 1 minus set 2, we get 4, 6, 8. Those are elements in set 1 that are not in set 2. So that's how difference works. Now moving on to the code in the slide. So I can show you what we have in the slide. It's not more complex, it just has variable name and all those stuff. So the first one here, I'm trying to find the elements that are in set 1 but are not in set 2. So I'm setting a variable result set. I'm putting set 1 dot difference set 2, meaning elements in set 1 not in set 2. So I want to print elements in set 1 but not in set 2, and I want to print the result set afterwards. I can do it like this. Then another one, I want to find the elements that are in set 2 now but are not in set 1. That way, I'm using set 2 dot difference set 1, same variable name. I remember in the last class I mentioned what F strings are, so I tried to inculcate it today. This is an F string here. As you can see, there's F and there's this bracket here having a variable inside of it. Without F string, we had to use a comma and then put the variable. But now with fstring, we just have to put the variable inside the bracket. So I printed elements in set 2, but not in set 1. Then I put result set in this bracket. So to give me this. So that's how difference works. Now we're done with sets and we're moving on to list comprehension loops. We've discussed loops and we've discussed lists. Now we want to discuss how to use loops on lists. So how to loop through lists. I think we discussed how to loop through lists, but now we actually want to use loops inside of lists. Right, so list comprehensions provide a concise way to create lists. They are used to work on a list and store a new list or array, and store in a new list or array. So we already have one list. We want to loop through that list to store it in a new list. And to do that, you have to put the old code in a list. Let me show you what I'm saying. So I'll not be mentioning this too many times and it gets confusing. So I'm going to create a list first. I have a list. Let me create a list. A random list of numbers. I'll call it list 1 equals to a list of numbers. For example, 1, 2, 3, 4, 5. So this is a list. We already have a list. So we want to work on this list. We want to loop through this list and then use our result to create a new list. And the only way we can do that is to use list comprehension loops. So I want to create a new list, right? So I can say list 2 equals to, I'm going to put bracket as path. I'm creating a list. And I'll put, for example, I want to do all the elements in list 1 raised power 2. I want to get the square of all the elements in list 1. I'll say x raised power 2 for x in list 1. Sorry. So x here is representing an element in list 1. And then this for loop is explaining what x means. Then I want to print list 2. So as you can see, I got this square. Oh, sorry, I put times 2, not raised power 2. So I got this square of all the elements from list 1. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 25. So what did I just do? I'll go over it again. This x here, I did not define it before. So here I'm putting x raised power 2. Then I'm now defining x. X is an element in list 1. This x in list 1 means that x belongs to list 1. X is an element in list 1 or is an item in list 1. So my aim of this, or the list 2, what I wanted from list 2 is to get the square of all the items in list 1. So I'm putting x raised power 2 and x represents all the items in list 1. So how this works is that it's the for loop loops through list 1, taking the elements one at a time and then performing the operation I mentioned earlier. That's x raised power 2, performing that operation on each x, and each x is the element in the list. So that's an example of how list comprehension works. And as I was saying, to create a list. Yeah, so list comprehensions provide a concise way to create lists. As you see, it is very short and very accurate and precise, very short, concise. I just created a list that way, putting list brackets and then putting what I want in the list instead of going on to define whatever. So I used to work on a list. I worked on list 1. Then I stored it in a new list, list 2. They followed by at least one for clause. I had a for clause which said for x in list 1. Then list comprehensions are a powerful feature that allow for elegant and compact code. So they make your code very compact. You don't have to be writing too much code. Your code will be very short, concise, compact. So this is an example of list comprehension. I tried to do 5 raised to power the numbers in a list. So I have numbers in a list and I also do 5 raised to power each number in a list.
Oh my god.
So my list is 13579. Then I'm creating a new list, which is 5 raised power x, and x is an element in list, or x is an item in list. So for x in lists, so I'm printing new lists, and the new list I'm printing is 5, 15, 25, 35, 45. Because I'm doing 5 times 1, 5 times 3, 5 times 5, 5 times 7, and 5 times 9. So that's how list compression loops work. Let me see if I can give another example on that so you can properly grasp the concept. Because it happens that many times you want to create a list from something you are working on. So rather than stressing it, you can just use this. Let me see another example I can give. I want to create let me say I have a list of, let me do list of numbers again. 2, 4, 6, 8. And then I want to find maybe the square root of each number in list 3. So list 4 is equal to, square root is represented as raised to power half, just like indices. So y raised to power 0.5 in a square root. And I'm saying that for y in
Like those, right?
list 3. Then, sorry, I want you to print out list 4 from me. So print list 4.
Nah, yeah, sure.
So as you can see, because the numbers here are not perfect squares, that's why I get in decimal numbers. So this is how it works. So here I just successfully printed the square root of all the numbers in list 3. Then, so the next thing we have here,
Naisha,
that's all on list comprehension loops. It's not a complex
Naisha, you just use
concept.
this. Eh? Why you tossing as I know?
Okay, next thing we have here
You
is file
scream.
handling.
Don't be tossing Naisha.
So
Play get same voice.
sometimes we need to work on files in our Python code, and then we can do this by reading the files from their
My
location
computer is
and
here.
then writing to the files. So as I said here, this involves reading from and writing to files. Working with files involves opening the file, working in it, and then closing it. So we have to first open our file, perform the operations that we want to perform on the file, and then close it. So yeah, the code here says, first, the first one is to how to write in a file. So I'm saying with open, I'm opening the file with that, with open. First thing I have to do is to open the file because the file is not open on my terminal. So with open, then I'll put the name of the file. Then comma W. W there means I want to write on the file. So I'm opening it as F as a file. Then I'm putting F dot write what I want to write on the file. So that way I've just successfully written something on the file. Then I want to now read the file. For example, in this first case, I'm trying to write on the file. In the second case, I'm trying to read the file. So still with open, then the name of the file. Then I'll put comma R in quotation. Then I'm opening it as F, that's as a file. Then I'm putting, okay, now I want to name my file. So I'm putting my variable name file equals to f dot read. So I'm using read function to read it. Then I'm printing out my file. Let me show you this.
Who was nothing now?
Show you so you can get how it works properly.
Now, Aisha. Okay.
Let's say pop on.
Don't sit down, Papa. Sit down.
So I want to open a file with, to start with open. Then we'll put the name of the file. Okay, so before we actually do this, we have to have a file that we want to write in. As you can see in this slide, I had a file that I wanted to write in. Sorry. Sorry, I just accidentally stopped presenting. As you can see, I had a file that I wanted to write to, and I had a file I wanted to open. The name of the file is missionjournal.txt because it's a text file. So how I do this is, I used the notebook to open this or to create the file. Then after creating the file, I brought it to the same location as my Jupyter notebook. Let me see if I can share my screen with you to explain that properly. So I'm going to be sharing my entire screen with you for a bit, so you can see how I did it. So yeah, I'm going to use Notepad. Then I just want to create a file, maybe name. I'm just going to write name in the file, so the file will be empty. Then I'll save it as sample file. Please, can you see my old screen?
Yes.
Okay, thank you. I'm going to save it as sample file.txt. Sample_file.txt. Save it as this. Then after saving that, I'm going to change the location. Sorry. Let's see. I canceled that instead of saving it, so I'm going to save it again. I can actually save it in the location I want here. I'm saving it into my Jupyter notebook directly like this. As you can see, I'm in desktop Jupyter notebook. That's where all my Jupyter notebook files are. So I'm saving directly into Jupyter notebook like this. So when I save it here, after saving it, then I'm going to go back to my Jupyter. Let me confirm that that has been saved. Sorry. Okay, I want to confirm that it has been saved. I don't think it has been saved. I don't know what's going on. So I'm trying to save it. I don't sample file. After saving it, I've saved it in my Jupyter notebook. As you can see, I have the files in my Jupyter notebook. After doing that, let me go back to the code. I think it has saved now. Like this. Since it's already in the same location as my Jupyter, I don't have to change the location or anything.
Somebody
But you
has a
see, we're not in the
question.
same
Sorry.
location.
Sorry, somebody has a question.
Okay, yeah, you can go ahead. You can go ahead with your question, please.
How do you pronounce this one now? Uduaka.
Sorry, you raised up your hand. You can go ahead with your question. Okay, whenever you're ready. So after saving the file, the next thing to do is to bring the file name here. Sample file dot text. Then comma write, because I want to write on it. So small letter W. as F. Let me see. Sorry, I've not completed what I'm supposed to write. So I'm writing F dot write because I want to write something on the file. And what do I want to write? I want to write maybe my name is Aisha. Let me see. So I've written my name is Aisha in the file. So now I want to open it with open. So I want to read it now. Sorry, read the same file name, comma, a small r in quotation to tell it I'm reading as F. Then F. Then I want to create a variable, maybe file equals to F dot read. Let's see what happens. So, sorry, give me a minute. I'll check. I want to confirm that the file was properly saved in my Jupyter. So let me show you this.
Yeah, started.
So yes, this here is the sample file that I saved. As you can see, it came to my Jupyter. This is my Jupyter home page. So this is the sample file that I saved. So it is here, and then I can work on it. So I just went to confirm it has been saved. So after this, the next thing I'll do is to call file, and then it brings my name is Aisha. So this is how to open it to write, open it to read, and then to confirm that you have written on it. If you open it here, it opens as a text file with my name is Aisha. If you recall, when we created this file, we didn't put anything inside, but I've successfully, from my terminal, written my name is Aisha into this file. That's how to open a file and to write on it. I can do another one so it is more understandable. So I'm going back to my notepad to create another empty file. I'm going to save it as file for Python. I'm going to save it as file for py. Save. Then I'm going back to my Jupyter. Then I'm going to open it the same way I opened the other one with open. So this open is saying you are trying to open the document the file, because the file is not open on your terminal yet. So first thing you have to do is to open the document. And to open the document, you have to put the file name. So what I named that was file underscore for underscore py dot text txt. So I want to open it, and don't forget I want to write in it. So I have to put a small letter W in the quotation mark inside the same bracket as I'm trying to open it. And I'm opening it as F means as a file. Then what I want to write in it, I'm using file.write. What I want to write on it, this is a Python class. This is a Python class. So this is what I want to write in it. Then now I want to read it to confirm that it's actually there. I can show you here in my Jupyter home page. As you see, this file for py.text was just added. So I can open it. And you see this is a Python class, is already written in it. I've just written from my terminal into this file. And I wrote this is a Python class. Then I can now confirm from my terminal that I've actually written it with open the same file for py.text. This time around I'm reading, so I'm putting a small r. I'm opening it as a file, so as f, then colon, and I want to read, so I'm putting f.read. Then my parentheses. Let me put a variable name here, file2 equals to this. Then I didn't run this. And I'm going to try to access file2 here. And it's giving me this is a Python class because that's what is in file2. In this example, I'm just adding sentences into a file. Sometimes you have to add like large information data into your file. So this is the same way you go about it. And then when you check your file, you'll see what you've written there. As you can see, I did not type anything here, but the information I put in my terminal came here. Also here, I didn't type anything, but it came here. So that is how to write in files. So now let's go back to the slide. And please, do you have any question at all before I move on? If you have any question, please try to react so I can move on.
Ma, please, when saving that notepad, did you that file on your notepad? Did you save the what was the document type?
Text.
Where the like text, right?
Yes.
Not all files.
Yes, sorry, I didn't get that.
Like when saving that document, that notepad was empty. Like when you were trying to save it, there's where you inputted the file name and the other column where it asks for file type. Was it all files or just the text file you selected?
TXT.
I saved my Notepad document as a text file. And when I was trying to open it, I opened it also using .text.
Okay.
Sorry, have I answered your question?
Yes, ma'am. Yes, ma'am. But just,
Okay.
ma, I hope this class is recorded like this.
Yes, it is. Okay, now back to the slide. The next thing we have here is handling exceptions. But before we move to that, the code here on file handling is just what I demonstrated. But here the document is called mission journal.txt. And then what I try to write in the document is it is my first day on the space mission. It is very nice. But the whole process is the same thing. I'm using with open, then the name of the file. Then I'm putting W here because I'm trying to write, and I'm opening it as F, means as file. Then okay, sorry, Victor, your question, you said something about why I'm opening as file or something like that.
No, what I was asking, like, when you were trying to save your, what is it called, that your notepad, the empty worksheet that you did not write
Yeah.
anything. When you try to save your document, like, did you, let me let me just check my notepad. There's this thing, sorry, let me just, okay, save as type. The save as type, is it text document or all files?
Text.
Okay, so I use text. I use text document.
The text
Text
document,
document, yes.
that's what I was.
Okay, you're welcome. So yes, I use text document to save it. And then I opened, when I was specifying the file name in my terminal, I use .text, but I'm opening it as a file. So I'm trying to access it as a file. I'm using f.write, file.write to write in it. And then to read it, I'm using file.read to read from it. But the same with open the file name, this small r means I'm reading from it and as f. Then I put a variable name equals to file.read, and I'm printing out the file. So this is just how to open your file, to write, to read, to write, and to check it. Then moving on is handling exceptions. How do we handle exceptions? So exceptions are runtime errors that can occur during the execution of a program. Sometimes we give a condition and then the condition is not true. So those are like exceptions and they can produce errors if we don't properly take care of them. So here I say the exceptions are runtime errors that can occur during the execution of a program. So yeah, they can come in form of errors because they are not properly catered for. And they can be handled by using try, except, else, and finally blocks. So now to now prevent the error, we don't want errors in our code so we can proceed. We have to deal with these exceptions properly using maybe try and except statements, else, and finally blocks. And these statements are similar to if else statements. So today I want to explain try and except statements and how to use it to deal with exceptions. So try and except statement. These are used for codes that have exception. Yes. The try block is first run and then the except block is run if an error is detected. So the way if and else worked that we gave a condition, if this condition is satisfied, do this, else do this. That's just the way accept try and accept statements work. So and there is for codes that have exceptions. For if and else, we're giving conditions, we expect them to follow the conditions. And we're saying, okay, if they don't follow the conditions, they should do this. But for try and accept, we're trying to say this is what we want to happen. But if it does not happen, just this should happen instead to prevent errors. To prevent errors. So for example, the code here is saying name is equal to Aisha. Then I'm trying to say if name is greater than 3, name and 3. Name is a string, 3 is an integer. Comparing them is not even possible. So I'm saying that if this is true, you should print hello, except that means if what I've said is not true, she just print an error was detected. If I do not put that except statement, I'll get an error, which can stop me from moving forward in my code. Let me show you an example of writing a code without an except statement. So I'm going to use the same example first before I use another one. I'm saying that name is equals to, right? So I want to try. So try is telling it, okay, do this. Try is telling it to do something first. And then after it tries that, then when it figures, oh, there's an error, then to do something else. So try, after try, put a colon. I'm using an if statement. If name is greater than 3, print, let's say print name. Then instead of using else, we're not using else, we're using except. So we're saying, okay, if what I've said earlier is not true, except. Then I'm going to tell it what to do if it's not true. Except should be at the same level with try. Sorry. Um, so except, and I want it to print an error has occurred. So it's going to print an error has occurred when I use try and except. So if I take this same code now, copy it, and then remove the try and except statements, I'll just use if statements. I just want to use an if statement. That means else print as you can see, there is an error because my comparison is between an integer and a string, which is not possible. So I'm getting an error because I didn't take take care of the error. I didn't consider it. But in the first one, I considered that, okay, if my comparison is not correct, what should you do? I told you that you should try to run my if-else statement. But if my if-else statement is going to give an error, it should just print an error as occurred. It is far better than me getting an error, because this way I'll be able to continue my code normally. But if I get an error in the middle of the code, that means from that middle till the end will not run because of that error. So the error will end up affecting the whole code. So to prevent that, my output will be an error as occurred. So when I see this output, I'll go back to check my code to look for the error. So that's the use of try and except statements. It is possible that the try statement is true. That way, the except block will not be executed. For example, let me say if name equals to Aisha, and remember that equal to is equal to from our former class. From our previous class, I mentioned that the assignment statement is equal to, and for when you have to compare, for comparison, use equal to equal to. So if name is equal to Aisha, print name. It printed the name because the code is true. It does not give an error. But for the one we did before, when we add an error, instead of it giving an error, it's printed an error as a code. So that's how to use try and except statements in your code to prevent errors. Because there's different times when these things come up. And then instead of you getting errors, to escape the error, you do this, so you can go back to the code and correct it, rather than the whole code just hanging and not finishing because of an error. So that is the end of session 4. That's all we have to deal with in session 4. If you have any questions, please ask before we call it a day. If you are good, please say so we can end the class. Please react or something. No questions. No, I don't get it.
Please,
Okay, you have a question.
that right with open this thing code you just did. Can you please rerun it again? I'm not really understand what you did there.
Okay, is it the last one?
Yes, before this second to this last one, that with open where you have to like import an external file. When you open your notepad there.
Okay, I should explain file handling.
Yes, ma'am.
Okay, let me try to do that before this call ends. All right, so I'm going to go back into the slide. I use the slide to explain. So file handling, like I said before, file handling involves reading from files and writing to files. So sometimes we need files that are not in our code terminal. We need external files, and we want to maybe write to them or check information from them, or we have information we want to save in them. So we need to bring in the files to our terminal and then put whichever information we have to put on it. And as you do this, we have to open the files, write on it and everything. So we already created files. Did you get how I created the files? Did you get how I created the files? I'm sorry, Victor, please, did you get how I created the files so I can move on?
Yeah, do you mean the notepad file or what?
Yeah.
You open your notepad and you save it.
Okay, yes. So I just created an empty notepad file. Then I want to open it now in my Jupyter notebook so I can write to it. So I'm going to use one of the files that I created earlier. That's sample file. That was the name of the file. So to do that, I have to say with open to open the file. Then the name of the file, which is sample file. Sample file dot text. Then a comma and then W in quotation mark. W is small letter. that's to show that I'm trying to write on the file. So I'm opening it as F. As F means I'm opening it as a file. And I'm putting file dot write. And I want to write whatever I want to write in it. Let's say this class is on file handling. So I've successfully written this. So I'll run it. To confirm that I've written it, I have to read it. I can read it, or I can just check the file, the original file. So let me show you outside Jupyter to confirm that I've actually written what I've written on the file. I can just show you the actual file first. So the file I just wrote on is sample file. I just wrote on sample file. So I'm going to open sample file here. This sample file.txt here. As you can see, what I have there now is this class is on file handling, because that's what I've written into the file. That's what I just wrote now. Then, apart from that one, I don't have to actually go and open the file to check what is in the file. So sometimes I just want to read what's in the file and bring it here to my Jupyter. So to do that, I can just say with open, file name again, dot text. Then don't forget your comma R to show that you are reading the file. And you're opening it as F, colon. I'm giving it a variable name. Let's say file 2 or file 3. Let's just say file 3 equals to f.read. And what do I want to read? I want to read what is in sample file. Put sample file.text. Sorry. I think I made an error somewhere. File. Oh, sorry. This should be just parentheses. The name of the file goes up, not in the parentheses here. So just parentheses. I'm not supposed to put anything inside it. So yeah, I've read the file now. Then to check what is in the file, I'll do this. And to give me this class is on file handling, which is what I wrote into the file initially. So writing and reading are two separate things. Sometimes you need to write and not necessarily read. Sometimes you need to read and not to write to a file. So it's just whichever you want to do. But this is how to write to a file, this is how to read to a file. Did you get it now?
Yes, ma'am. Yes, ma'am. Thank you.
You're welcome. So if there's any other question, this class will be ending in 5 minutes. If there is no other question, I'll send the assignment to the group. I was supposed to send it from the last class, or after the last class rather, but I did not because the assignment has to do with reading files. So I'll send the assignment after the class now. Please do your assignment and then see you in the next class. Thank you.